What about if I tell you that superposition theorem is the simplest thing on earth? Okay, watch what I saw. In a circuit containing several sources of EMF, the resultant current in any branch is the algebraic sum of the current in that branch that would be produced by each EMF acting alone, all other sources of EMF being replaced meanwhile by their respective internal resistance. Okay, the first thing you're joining us. If I can solve this cycle and determine the current and the direction using superpositioning theorem. Using superpositioning theorem. Okay. Solve these cycles and determine the direction of the current. Finding I1, I2, and I3. Okay. Assuming we have a circuit like this. Let's say E1 equals to 15 volts. E2 equals to 10 volts. Call this 2 ohm, 3 ohm, 4 ohm. Okay? And we have currents. I1 here, I2 here, current I2 here. And we have to solve this. Determine the currents in this circuit in this portion using superpositioning theorem. Now, very simple. The first thing we're going to do is that we're going to short circuit either the voltage of E1 or the voltage of what? E2. Any of them which we love to short circuit, we're going to try this. Now, in order to know this, I'm going to show you simple ways, simple tricks, and how you can solve it easily without you wasting your time. Okay. First, I'm going to short circuit E2. Now, when I short circuit E2, E2 will be equal to 0. And I'll be having the same circuit exactly like this. Here, 4 ohm, I1, 15 volts, ohm, 2 ohm. Okay, and here is I2, I3. Now, when E2 is equal to 0, so I've removed E2 here, E2 have been removed. Okay, then we're only left with E1, which is our voltage 1. Now, the first thing we're going to do is that we're going to solve this resistance, which is also here. We're going to make it 1 by solving it in parallel formation. That is 3 parallel 2. You're going to find the equivalent resistance. That it will merge together and be in series with 4 ohm. Are you getting it? So now, I'm going to solve that. You're going to have equivalent resistance, equivalent which we know as RAQ, to be equals to 3 parallel 2. And that is 3 times 2 over 3 plus 2. And this will give us 3 times 2 is 6, 3 plus 2 is 5. So, this will give us 6 divided by 5 is equals to 1.2 ohm. Or you can look at it, just do this, the root of 4 to 5, no, put 6 in, 5 out. 6 divided by 5, we have 1. Okay, 1 1 times 5, 5, minus, since we have 1, period point, add 0 here. So 10 divided by R is 2, 1.2 ohms. Okay? With that, we have gotten our parallel resistance, our equivalent resistance. That means these two here are merged together now. I want to withdraw this circuit. This is how it looks like now. Okay, so this actually look like exactly. So this are joined together here. Okay, so from here now, if I want to look for my I1, because at this point, current I1 is the only one flowing here. Okay, so current I1, I1 is flowing. I1 is flowing here. So what I'm going to do now is that I'm going to look at how do I find my I1. From Kirchhoff current law, we said I1 is equals to V over what? V over R. Remember these two are now in series. So for series, we have voltage to what? 15. What about for the series resistance now? I'm just going to add them together. It's going to be 4 plus 1.2. Okay. So 15 will give us still 15. 4 plus 1.2 will give us 5.2. Okay. Exactly. So 15 divided by 5.2 will give us what? To the 2.885. So we are looking for our I1, which is 15 divided by 4 plus 1.2. How do we do that? We just added this together as a result. V over R. 1.2 plus 4 is 5.2. Our voltage is what? 15. 15 volts here. We have 2.85 ampere. So we are looking for our first current. We're going for I2 and I3 now. Then after that, we're going to short circuit the other side, which is E2, which is E1, to get E2, and we're going to get our I1, I2, and I3, the same thing, consecutively like the way we had the first one. So with that, I would like to solve it. Thank you. Okay, so I2 now will be equals to, and this is what we call when I2 is coming from. And actually, we are dealing with this particular part. This whole circuit, we're dealing with all this side like this. So for I2 and I3. So for I2 and I3, we're going to say resistance R2 will be divided by R2 plus R3. That is this 2 ohm will be divided by 2 ohm plus 3 ohm. Times what we have, which is what? I1 times I1. And it gives us something exactly like, what is R2? R2 here is what? 2 ohm. Or 2, let us say 2. Divided by R2 again is equal to 2. Plus 3 times, what is our I1? 2.885. This is very, very simple. Just this divided by the sum of this. The same thing we're going to look at, get our I3. Our I3 will be 3 divided by the sum of this both times the current again. That is current I1. Okay, so 2 divided by 2 plus 3 is what? Is 5 times 2.885. So our final answer will give us 2 times 2.885. Anything you have divided by 5. So answer will be 0.154 ampere. That will be our final answer for I2. The same thing, it will still be R3 divided by R2 plus R3 times I1. The current to solve for. And R3 will be, R3 is 3 ohms. So 3 ohms divided by the sum of these volts, 3 plus 2, times our current, I1, which is 2.885. So punch it on your calculator. The final answer should be 1.731 ampere for I3. So we've gotten our I1, I2, and I3. The next thing, direction I1, I2, and I3. We got I1 using Ohm's law. Then with that, we get our I2 and I3, as simple as that. Okay, from this now, we want to look for, what about if I short circuit this place too? Then this place will be open wire will be short circuited. Okay. So I'm going to be having something exactly like this. We draw the circuit. So we draw the circuit. I'll be having, okay. So I will not have voltage for here, but I've short circuited it. Here we'll be having voltage, which is 10 volts. That's our E2. Okay? Here is 2 ohm, 3 ohm, 4 ohm, I1, I3, I2. Now we are asked to solve it now. Why E1 is equal to 0 volt. That means it has been short circuited. But for this point, all the current will be going in this direction. That means the opposite direction. And when they are going in the opposite direction, our I3 will be going like this. So we are going to solve our I3 first. And I2 will be negative. Our I2 will be negative, but our I1 is the only current that is flowing through point A. And that's the point A here. That's the point B here. Okay, so for that, I am going to look for I3 first. Before I look for I3, we're going to look for the equivalent resistance at this point. Now, the equivalent resistance will be our equivalent resistance will be 4 parallel 3. Because this is what we are dealing with actually, so we don't move it. We are only going to move it. It's 4 parallel 3, and that is meaning of 4 times 3 divided by 4 plus 3. If you have any question, inbox us. So this is going to be 4 times 3 is 12 divided by 7. So final answer, yours, find it. Put that 12 yourself, 7 your 1. 1 7 7 minus 6. Yeah, okay, we have 3 5 3 5. We have 2 0. Okay. We have 7 here. 7 plus 7 plus 9. Now say we have 10. Okay. We have 1. We have 7. We have 3. That's 30. 28. That was 2. Okay. No 4. 4. 28. Now we have it to be 20 again. Just 2. And continue like that. Let's just top out. 20 bits. And give us 1.714. Okay, so from here, we're going to look for I3. I3 is actually the one flowing from to this point, to this actual point, while I1 is not flowing from this point. So we're dealing with this second case, that's right. So I3 is going to be equals to B over R, and that is going to give us exactly B will be 10 divided by our summation of resistance, which we are going to have 1.714 plus 2. Okay. And that should give us 10 divided by 3.714. So our I3 now will be equals to 2.693 ampere. So having that now, we can proceed to look for I1. So how do we get I1? I1 now will be actually going to this direction, and that is going to be 3. But we're dealing with this 2 resistor, 4 ohm and 3 ohm. It's actually going to this point here. This is only current going to this node A. That's going to be 3 divided by 3 plus 4 times I3. So this I3 will look for first using B over R. So anyone you use B over R to look for, that's going to be multiplied by. So now 3 divided by 3 plus 4 is 7 times 2.69. Okay, so 3 over 7 times 2.693. If you punch your calculator, that is when you say 3 times 2.693 divided by 7. Your final answer should be resolving to 1.154. Okay. Ampere. Okay. Now, what about for I2? Yes, I2. Now, I2, as I said, is having an opposite direction. So, it must be negative. One is going backward. Okay, so it's going to be minus 4 over 3 plus 4 times I3. And that is going to give us minus 4 over 7 times 2.693. And that will give us minus, total answer should be 1.539 ampere. What? At the final stage, so at the final stage, I'm going to withdraw the circuit again. Now, when I withdraw the circuit, I'm going to show you something. As this, you're going to be having I1, another I1, I3, I3, I2, I2. I mean, there's 2 current and I1 here, 2 current I2 here, 2 current I2 here. So today my I1, that means current flow at, let's start from 4 ohm resistor, at 4 ohm resistor is equals to I1 plus I1. And that is I1 plus I1. And the first I1 we got, our I1 was 2.885. You're really following me? 2.885. Anyway, I've played the board already, but we only have this one just so anyway. So follow me, you have seen that the first I1 was 2.885, and the second one will be 1.154. Okay. In summation, this will be added, and at 3 ohm resistor, the current flow here is I2 plus I2, and that gives us the first current for I2 was the second current for I2 was 1.154 plus minus 1.539. So we have here first I2 to I2 1.154 plus minus 1.539. That's for I2 here, that's what here. Okay, and for the last, now it's 2 ohm resistor, current that flows here is I3 plus I2. And that gave us, I think that gave us, first one here, we solved it to be giving us 1.731, yeah, I'll do that, 1.731, and plus the second one gave us 2.692. Now, we can now add them together, and let's know our final answer should look like. Okay, it's great. How it should look like. Now we have 2.85 plus 1.154 plus together. This goes 9, this goes 5, 13, 9, 10, 3, 4, 4.039. Well, yeah, 1.154 minus 1.539. Okay, so after that, we find out. That I will do this. Let's see, 1.539 minus 1.54. 1.554. And then plus 4. Then plus 4. Plus 6. 4.1. 0.7. Minus 0.384. And last one is we have 1.731 plus 692. And then we have plus 4. So it's 14. 4,400. So that's our final answer for today. Solving superposition theorem. Okay. Classwork. Solve this using superposition theorem and tell me your final answer. Let's go there.